Hey guys, in this video I'm going to be going over how to do the day 10 warm-up and the day 10 in-class practice worksheet. So to start with this warm-up, this is really a pre-calc problem. You did these last year. And normally this would look like a pretty easy unit circle problem. You know, where is the cosine equal to 0? However, it's a little bit trickier than that just because we have this 3 in here. It's really what angle could we take and multiply it by 3, and that angle has a cosine value of 0. So you kind of got to make it a little bit easier on yourself. And what I would do is I would give this 3x a new name. I would say let's call it theta. So I'm just going to write this out. We're going to let 3x equal theta. In step 1, we're really just going to rewrite the problem. Instead of a 3x here, I'm going to put a theta in there. Cosine theta equals 0. All right, so what that does is it temporarily kind of changes the problem. It makes it easier, and then later we'll go back in and kind of deal with what we changed the problem as. All right, so here on our unit circle, where do you have a cosine value of 0? If you're not sure, you know, think about your unit circle. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi, and these are your points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, remember, and if we're trying to figure out where is the cosine value 0, what angle, that's where is your x value 0, which our x value is 0 at pi over 2, and also at 3 pi over 2. So really, if we were solving this equation for theta, all right, we would get that theta is pi over 2 and 3 pi over 2. All right, something to point out, those are not answers. All right, our goal was to solve this equation right here. There were no thetas in it. There were x's in it. So really, we don't have the answers yet. So really what step 2 is go back to the fact that we changed the problem. We changed this from 3x to theta. So go back. We knew that 3x is really equal to theta. And I'm going to write that out. I found 2 values for theta, so I'm going to write this out twice. And we're literally just going to substitute our values in for theta. So 3x equals our theta that we found. One of them was pi over 2. All right, the other one, 3x equals our other theta was 3 pi over 2. All right, I just plug those values in. And what I'm going to do is just solve for x. And I probably think the easiest way is just to cross multiply. Put this 3x over 1. You get 6x equals pi. And we're trying to solve for x here. Divide both sides by 6. All right, and x equals pi over 6 is one of your answers. Same thing with the other one. Here we're trying to solve for x. We're just going to cross multiply. Get 6x equals 3 pi. Divide both sides by 6. So our answer is 3 pi over 6, which we know can be reduced to really pi over 2. All right, so those are going to be 2 of our answers. That's really just considered the first set of answers. I might just write that over here. And if you remember from pre-calc, actually, this cosine 3x at the top, because there's a 3 up there, that actually means there's going to be 3 sets of answers. All right, so we need to kind of keep going. So how you find the other sets, you kind of start over down here, all right? And you have to find the period of this graph. Cosine 3x, what's the period? Whatever it is, you have to add it to these answers, and you'll get the second set. Once you get the second set, again, add the period to those, and you'll get the third set. All right, so kind of our step 3 here is to find the period. If you remember from last year, period of a cosine graph is 2 pi over b. And b is just really that number in front of x. So 2 pi over 3 is the period. All right, and we have to add that to pi over 6 and pi over 2. All right, so if we do that, another answer for x is going to be pi over 6, which was our answer up there. And we got to add our period to it. Add 2 pi over 3. We got to figure out what that equals. All right, we got to do the same thing for our other answer, pi over 2. And we have to add our period to it. These are not ideal because they don't have a common denominator, so I would try to get one. All right, think about this 3 right here. To make it 6, we could just multiply the top by 2 and the bottom by 2. All right, so really what that would be pi over 6 plus 2 times 2 is 4, 4 pi over 6, and if you add those together, you really get 5 pi over 6. All right, that's another x value. I'm going to put a circle around it. That's another one of my answers. All right, same thing down here. We got to get a common denominator. Probably 6 is the easiest way. To make this one 6, we could multiply by 3 over 3. To make this one 6, we could multiply by 2 over 2. And really what we get is 3 pi over 6 plus 2 times 2 is 4, 4 pi over 6. And if we add those together, we get 7 pi over 6. All right, this right here is our second set of answers. We're getting close. All right, we are not done. We still need a third set. All right, and I'm kind of running out of room. I'm going to get some extra paper here. All right, I'm going to take that set right there, those answers we just got. And at the last step, the answers we just got were 5 pi over 6 and 7 pi over 6. All right, and we have to add the period again to it. Again, that period is probably not ideal because it doesn't have that denominator of 6. All right, but 2 pi over 3 with a denominator of 6 is really 4 pi over 6. So I might just use this version. That's really the period. Just kind of another way to write it would be 4 pi over 6, just multiplying the top by 2 and the bottom by 2. So I'm just going to write it as 4 pi over 6. We have to add the period to those answers. And if we do that, we get 9 pi over 6. All right, and 11 pi over 6. Again, this is another x value. This one can probably be reduced. If we divide by 3, we get 3 pi over 2. All right, and it looks like that is our third set of answers. All right, and really all that is where this graph would equal 0. All the x-intercepts on it from 0 to 2 pi. We found them. There were actually 6 answers right there. All right, let's look at the in-class practice next, now that we reviewed a little bit of that trig. All right. This front side, I would say you guys should be able to do this on your own right now. I would pause the video and try to do this all on your own, but this is really just a review, and I'm just going to give you the final answers, but you are expected to show all your work to get these answers. So please do this on your own. Again, these are just the final answers to check. This is -7. This is going to be 18 over 25. This is going to be -4. Remember, these questions are really similar to what was on that derivative quiz that you guys took. Number 2, the answer should be 3x squared times e to the x plus x to the third plus 2 times e to the x. 3, you should definitely do your quotient rule there and get x squared plus e to the x times cosine x minus sine x times the quantity 2x plus e to the x all over x squared plus e to the x all squared. All right, and then the last one, the final answer should be 3 times sine of 5x squared, all of that squared, times cosine of 5x squared times 10x. And again, please show any work that's necessary there. These are just the final answers because this is really just extra practice from what we did on the quiz. All right. On the back of this is more where you need to know what we did in the warm-up. All right, it says, let f of x equal this, and it says find all the values of x on 0 to 2 pi where the slope of the tangent line is equal to 1. And you're allowed to use a calculator. So let's talk about this. This is f of x, where the slope of the tangent line is equal to 1. First of all, slope of the tangent line, that's just the derivative, right? So if this is f of x, slope of the tangent line is really just f prime of x, and we want to know when it's equal to 1. So we got to figure that out. We should probably take the derivative of this and then set it equal to 1. Really what we're looking for is if we take the derivative, what x value could we plug in where it would be equal to 1. So we kind of got to work backwards in this one. So step 1, let's take the derivative here. All right, derivative of x is really just 1. All right, the derivative of sine, we learned the trick for that yesterday. All right, we said this kind of chart can help us remember that. Maybe take time to write it out if you don't have it memorized yet. All right, but it's really kind of just that unit circle that can kind of help you out. So what this says is the derivative of sine is cosine. But we have a little bit of chain rule in here. This is an inside function. So we're supposed to take the derivative of the outside first. Derivative of sine is cosine. We're supposed to leave that inside function the same. And then we're supposed to multiply by the derivative of the inside, which is really just 2. All right, so that's our derivative. We were supposed to set that equal to 1 and solve. So let's do that. If we're going to take that right there and set it equal to 1 and try to solve, we need to solve for x. I try to get this by itself first. So let's subtract this 1 over here. If we do that, these cancel. We're left with cosine of 2x times 2 equals 0. Probably the next thing, we can divide by that too. Just kind of get rid of it. Divide by 2. We're left with cosine of 2x equals 0. All right, we have to solve this. And again, they're saying we can use a calculator. All right, on the warm-up, we would have done this by hand and kind of called this theta, solve for theta, and then plugged it back in and solve for the x's. But we can use a calculator. So really, we just want to know, when does this graph hit 0? Or where does it have its x-intercepts? On 0 to 2 pi. So let's talk about how we could do this in our calculator. First of all, we should always be in radians. So let's just double check this. See if I turn this light on. It'll help you guys be able to see. All right, I'm just going to check to see. I need to be in radians. All right, and we're really graphing cosine of 2x. And we want to know when it's equal to 0. So I might just put in 0 as well. And we need to set our window. We only want the answers from 0 to 2 pi. And then if we also think about this, all right, our amplitude of this, the number out in front, is just 1. So really the graph is only going to go up to 1, down to -1. I might make my y min and max -2 to 2. And let's see if we can see this graph. All right, we want to know when this graph is equal to 0. You could do second trace 0 to find all those. I actually graphed 0. So we have 2 graphs on there. 0 is just this horizontal line. That's the x-axis. We could just do second trace intersect, and it'll give us all those answers. I might go left to right. Let's get closest to it gives you the closest intersection that's closest to your pointer. So we want that one right there. Press enter 3 times. That's one of our answers. 0.785. Remember, in calculus, you always need to round to 3 decimal places. 0.785 is one of them. All right, next one, second trace intersect. Before I start pressing enter, I'm going to get close to the next intersection point. Press enter 3 times. All right, another one is 2.356. Keep going. Second trace intersect. Press enter 3 times. We got 3.926. Remember, you're allowed to just cut it at 3 decimal places or round up if you want. I just like to cut it. It's easier. One more. Second trace intersect. Press enter 3 times. You get 5.497. All right, so those are your 4 answers. Remember we said we had 2 sets of answers right here. That's because we had 2 periods going on. All right, if we were doing it by hand, this would have been a period. These would be the first 2 answers, or the first set. These would be the second set. And again, how we did it by hand, if we found the first set, we just took the period. If you add the period to the first answer, you get the answer that's a period away from it. Take this answer, add the period, you get that one. So we just kind of did it by hand in the warm-up versus this was just doing it on a calculator. All right, and that's our answer. Find all the values for x where the slope of the tangent line was equal to 1. All right, next question. It says let f of x equal x plus sine of 2x. Same problem as number 6. All right, it says find all the values of x where the slope of the tangent line is equal to 1. Same exact problem. Now we just can't use a calculator. All right, so think slope of the tangent line equal to 1 means f prime of x is equal to 1. Same setup as before. Our f prime was 1 plus cosine of 2x times 2 equals 1. We'd still solve it the same way. We're not allowed to use a calculator, so these cancel. Cosine of 2x times 2 equals 0. Divide the 2 out. Really what we're doing is cosine of 2x equals 0, and this is really the step where we just graphed this on our calculator and found these answers. Here we need to do it by hand like we did in the warm-up. So again, things to think about. This 2x means there's 2 sets of answers. And we said in the warm-up, this is kind of a hard problem to do by hand. Normally a unit circle problem would just say kind of cosine of x equals 0. Because of this 2, it makes it harder. So usually what we do here is we just say step 1, we're going to let theta equal 2x. And we're really just going to rewrite the problem. Cosine theta equals 0. Just putting a theta in the 2x's spot. That makes this a pretty easy problem. Just where is your cosine or your x value? 0. We should know that. Where is your cosine 0? It's at pi over 2 and 3 pi over 2. And again, those are not answers. If we're trying to figure out values of x right here, there were no thetas in the problem. All right, so go on to step 2. We have to go back to the fact that we changed the problem. There was a 2x and we called it theta. So go back to the fact that theta was equal to 2x. And now we got to plug our thetas in here. So pi over 2 equals 2x. The other one, 3 pi over 2 equals 2x. And we can cross multiply and solve just how we did in the warm-up. So I'm going to put this over 1. You get 4x equals pi. Divide both sides by 4. You get x equals pi over 4 here. And over here, cross multiply, 4x equals 3 pi. Divide both sides by 4. All right, remember, this is the first set of answers. All right, we need another set. So we said we need to find the period and add it to those answers. Because really what we just found, if we go back to our graph on our calculator, all right, we found this answer and this one. So if we know this answer, add the period, that'll get us this answer. Know this answer, add the period, that'll get us this answer. It's a period away. All right, so think step 3, we're going to find the period. The period formula is 2 pi over b. Our b value was that number in front of x. This is really what we're trying to find. It was a 2, so 2 pi over 2, which really just turns out to be pi. However, if we're going to have to add it to these answers, they have a denominator of 4. I would get a common denominator of 4. Let's call that 4 pi over 4, just to make it easier to add with those. So the answers we got to begin with are pi over 4 and 3 pi over 4. We need to add our period, 4 pi over 4, to those to get our second set of answers. If we do that, we get 5 pi over 4 and 7 pi over 4. And those are our other answers for x. All right, and these are actually the exact same answers as our other ones up here. We could check it on a calculator if we wanted. Probably an easy way would be to do second trace value on our calculator and just make sure those are those x-intercepts that we found before. So I'm going to show you guys. We just found pi over 4 is an answer. What if we did second trace value, plugged in pi over 4? It's lighting up at the x-intercept. Same thing with the next one. 3 pi over 4 was one of our other answers. It's the x-intercept. Second trace value, 5 pi over 4, it's the x-intercept. All right, and one more, 7 pi over 4, it's the x-intercept. All right, so That's kind of the way you can do it the long way by hand, or if it was a calculator problem, you could just do it on a calculator and round to 3 decimal places. All right, moving on. These ones say thinking backwards. All right, it says find f of x if you're given the derivative. So you really got to think backwards here. All right, so I'm looking at this, and it might be a little bit tricky, but if you see an e, remember the derivative of e is itself. All right, so I'd be thinking we probably started out with this if the derivative is itself, but if this was the inside function, we'd have to take the derivative of that, and maybe that's where this part comes from. If we just kind of review our rules about sine and cosine, this is cosine, this is negative sine, this is negative cosine, and this is positive sine, and it kind of goes around this way. All right. Think about if our original function was e to the cosine x. If we took the derivative of the inside, derivative of cosine is negative sine. That's probably where this negative sign comes from. So I would say our original right here would have to just be e to the cosine. And you could always just check and ask yourself, okay, derivative of e is itself, leave the inside function alone. Derivative of the inside is negative sine, and that's where that negative sign comes from, in front. Remember, the order doesn't matter. You know, maybe normally we would write this first times a negative sign. It doesn't matter the order that you're multiplying in. All right, this next one, same thing. If it has an e in it, probably be thinking e to the cosine. That was probably part of the original. So let's just write that. If we think e to the cosine was in it, all right, think the derivative of that is itself. However, the derivative of the inside of cosine is negative sine. We don't have a negative here, but we do have a sign. So think about if there is no negative there, maybe there was a negative in the original, because then when you take the derivative and you have another negative in front, it becomes positive. All right, but there's really no explanation for this 2 right here. So maybe let's just kind of put a 2 in there. You guys know constants, you just kind of work around. All right, so I might even rewrite that. If I just have this negative in front, this 2, and we have e to the cosine, let's just double check because this one was kind of hard to think about. If we were to take the derivative of this, this is what we think our answer is. A negative 2, we just work around, so we just kind of leave it there. Derivative of e is itself. But derivative of this inside function is a negative sign. We'd multiply by a negative sign. And then think about that. A negative times a negative is a positive. We could write it as positive 2 e to the cosine times sine. And just double check, is that what we started with? We have a 2, we have a sine, we have an e to the cosine, so we know we did it right. All right, so really either way, this could be your original function, or you could write it this way. They're both the same thing. All right, and then the last one, it says find the 31,415th derivative of cosine. Well, we know these rules. We know they kind of repeat. This is the first derivative of cosine, the second derivative, the third derivative, the fourth derivative, and then they start repeating, kind of in increments of 4. So we probably got to figure out, where would we end up if we go 31,415 times? That's how many times we move. So I'd probably take this number and divide it by 4, because again, if you go around 4 times, 1, 2, 3, 4, you're back at what you started with. So let's just kind of take that number, 31,415. If we divide that by 4 on a calculator, let's see what we get. 31,415 divided by 4, I think we get 7853.75. Maybe change this part to a fraction. That means we're going around 7853 times, and 0.75 is really 3/4 as a fraction. All right, so if we divide by 4, that tells us how many times we're going around the circle. We're going around this many times, all right, and then another 3/4. So think about if we complete these, we'll be back at cosine. If we go another 3/4, 1, 2, 3. That's 3/4 around the circle. The answer would be sine. All right, so that's kind of how you could think about a problem like that, because derivative of cosine, or really any version of cosine or sine, just repeats itself over and over again. All right, that's all I got for you guys today. Your homework is day 10 in the book, and also that extra half sheet of paper called the day 10 homework add-on. All right, good luck doing that, and I will see you guys on Monday.